And I believe that's presenting. Okay. Let me make sure I'm all good. Yeah. So we're going to be covering natural language processing today. I'll go ahead and introduce myself. So I'm Ashley Ragosa. I really like to code, and machine learning is like my niche, and I love NLPs. We're going to be going over pre-processing and a fact writer today. So we'll be going through how text is basically brought down to its bare bones so the models can read it, and also how we can pull specific facts out of a big paragraph, like when you take notes in class. But we'll be doing that with a model. So that'll be really fun. So first question is, how can a machine possibly understand language? So computers can process natural language, and natural language is essentially English, Chinese, French, any language you could think of. Anything that we speak is considered natural language. And a machine has no clue what that is. Basically, a computer is only the transistors that are either 0 or 1 that can determine what it does. And obviously, language is not in the format of zeros and ones. So NLPs is all about transforming these pieces of text into only binary digits. And it's super fun to do, and I'll go ahead and I'll walk you guys through how to do the main parts for that. So you may have heard of Alan Turing before. He stated you can never write a computer program that could debug all other computer programs. His main thing was basically understanding how machines work and the future of artificial intelligence. The main part that Alan Turing emphasizes in a lot of his research is that computers do not process things the same way we do. So the way they understand text is not going to be the same way we do. So our brain uses neurons and other biological factors, while computers only going to be using binary digits, as I had said. So that's a really interesting point. And the coolest part about that is it was all the way back in the 1950s, and he already knew about this concept. That's so cool. So the next part is, let's look how a computer processes things. So you first start with sentence segmentation. You could always start with other forms of pre-processing, but I'll go ahead and introduce you guys to sentence segmentation first. So Alan Turing was a cryptanalyst, is just a sentence that we may input into a machine learning model. A cryptanalyst is just someone who deciphers codes. Like if the Germans were giving fancy little codes that were illegible to us, but legible when you decipher it and you're able to transform it back into text. So that was his job in the 1950s. Or around the 20th century approximately. So that is a sentence that the computer can break down. So we have to convert this into something where it's only the bare bones, as I had mentioned, of the sentence. So it'd probably end up turning into Alan Turing is cryptanalysis. So we get rid of any unimportant words like a, and, the, that the computer really doesn't need to understand these programs. So I have some other samples of different sentences, and I also highlighted any important keywords the computer will most likely think is extremely important to understand the text. So when you look at this, you mostly look at cryptanalysis, or broke, enigma code, saved, lives. So it shows the computer would process this and understand, okay, so Alan Turing worked with computers. He worked with whatever enigma code is. The computer's not going to know what this is. This is something to do with history and breaking and deciphering codes of German texts and during the war. And the last one is how he was considered a hero. So the computer would process all of this and understand the keywords only. I really want to emphasize that it's only pulling the keywords, not the full sentence. And I just have a little thing on the right. It kind of looks like something you'd see in a kindergarten class. And I did this because computers are like childs, especially machine learning models. So they're always learning at an extremely fast rate, except you have to consider that they're learning all this from scratch. So they don't know that birds can fly or that reading is considered fun. This is more opinionated, except it would have to take these inputs and finally understand, what does this really mean? So we can input these kinds of facts that say birds can fly in real life. And then the computer would go, okay, so this is a fact that birds can fly. But it wouldn't know that from the start. And I really want to emphasize that. So let's go directly into pre-processing using stop words, which I had mentioned before, like a, the, in, anything that's unimportant. And I have a sentence up here by Einstein, states, insanity, doing the same thing over and over again and expecting different results. You'll see below it, it says, insane, same thing, over again, expect different result, Einstein. That sounds, it's almost impossible to understand, but you get the gist. So it's insane, which is the same thing over and over again, and you think there's going to be a different result. So that means the computer will understand the second one better than it'll understand the first one, because it gets rid of all of that noise in your data. So go ahead and transform it. You'll also see using stop words down here. Instead of spaces, they're using commas. And basically that's just how a computer will break it down. I thought those were some really cool examples. And over here, you'll notice, I don't know if it's NER or NER, I'm gonna call it NER, except name entity recognition. Over on the one with Alan Turing, it would have kept his name, because it will use name entity recognition to recognize names, organizations, businesses, and more. And you can find these in different Python like libraries that can recognize these as names and not actual words. So instead of trying to figure out what's geeks for geeks, that's not a word, it will recognize, oh, that's a YouTube channel, or oh, that's an organization, instead of getting really confused about it. Because if I had no knowledge whatsoever of what that is, it would become very confusing to decipher what the person just said to me. Also, if you guys have any questions, just say something in the chat, or you can, it's easier for you to just say it out loud, just interrupt me through the mic. I'm not able to see the chat super well while I'm presenting, but I just want to remind you guys, if I'm going too fast, just tell me. So let's go into tokenization. Tokenization is extremely important for your machine learning models. It's something that breaks your text down into solely, like think of an array and having a whole string in it, and then breaking it down into each word, where each word takes up one index. That's essentially what your model will be doing. So it'll start with pre-processing, things like getting rid of stop words, as I had mentioned, and then it will go through tokenization. And it's called a token because think of it as like tuning it for different weights. So your model will go ahead and look at all of these different words in your sentence and then go, okay, so I saw this word this many times repeatedly throughout this whole data set. This word must be important. So it'll assign certain weights that are coordinated between the certain word and the result. So normally when you have a data set, you'll have, let's say, a piece of text in one column, and it'll go all the way down, let's say 20,000 samples. It normally has to be a lot for NLPs, because you're basically teaching a model a whole new language, and you have to make that equivalent to what you've learned in, let's say, 16 or a range of 16 to like maybe 12 years, and you have to make that model learn it in maybe under an hour. So you have to give it as many samples as you possibly can. It's so vital that you give it as many samples, because you don't want to inaccurately classify something. So, excuse me, my voice is like not cooperating today, but you would have a column for your text, and then you'd have your result. So recently I created a model for analyzing depression. And we pulled a bunch of text that had our column, which was depressive text, and 1 was equivalent to, it had a binary output. 1 was equivalent to depressed text, and 0 was equivalent to non-depressed text. So essentially it had 2 separate results, and it would try to decipher, okay, what common contexts or keywords are coming up in our depressed text versus our non-depressed ones. And from that, it can tokenize our sentences and then assign weights to each of these words. And that's essentially how it goes through the whole process. A really important topic is lemmatization. You'll also see something called stemming. I'll go over that in the next slide. And it's converting your sentences into only the root words. So it will take the noun or the verb or the adjective of your sentence, and it will be able to classify what's probably the most important part of this text. So I have a sentence right here. I wrote it myself. It says, I ate 2 chicken nuggets. So ate is our verb and chicken nuggets is our subject. And the model will recognize this and go, okay, so this person did something with chicken nuggets, and this is very important. But you have to realize that computers can also understand context, as I had mentioned before. And if you only focused on keywords in a sentence, it would skip over the important ones that have not come up in this database of keywords you've assigned your model. So let's say I assign my model words like from before with my depressed text analyzer. If I only assigned it words like depressed, sad, it would never pick up on words that weren't exactly depressed or sad. So it would miss words like, I'm trying to come up with other synonyms for depressed. But basically, if it doesn't see a synonym, it will completely miss the purpose of the text. So you have to make sure it understands the context and how is this person speaking? Why are they speaking like this? How does the way they're structuring their sentence lead to them being depressed? And the model will pick up on these features if you train it correctly, which I will explain with different libraries like TensorFlow and Keras. So right over here, you can see some basic images also, and it's essentially just breaking down the sentences into the verbs and the subjects. So stemming versus lemmatization. Stemming can be a word that's not real. So when you apply lemmatization to a model or the text in the model, it will turn it only into the root word. So as you can see here, change would become change because that's the root word. Changing becomes change, changes becomes change, and so forth. So it gets rid of the ending on there. Except over on stemming, you notice how it turns into, I guess you call it chain. I'm not really sure how to say it, except it's not a real word is what you'll notice. And it'll cut off everything that it possibly can that's similar between these texts. So it went ahead and got rid of everything that has an E because it goes, okay, so the only things that are in common with all of these texts are C, H, A, and G. And it'll go, well, I don't need the E, that's extra data. I don't want to use extra data because it takes me more time to process that. Right? So essentially it will go ahead and cut off anything that goes, I don't need that to figure out what the answer is. So you will apply this to all of your text. You do not want your endings on your words. It will clutter your data. So let's break down this whole process. So in our text document, we will do sentence segmentation. As I had mentioned before, I'll go ahead and review all of these to make sure they're kind of like solid before we go into actually programming. So sentence segmentation is breaking it down into the basic words, and you will segment it out into the most important parts, including the parts of speech tagging, which is your verbs, adjectives. Tokenization plays a role in, as we had mentioned before, it was assigning different weights. And right here is assigning different weights, tuning your model. And it will break these down into like a separate index for each of the words in the sentence. And then we'll apply lemmatization, or you could do stemming. You could choose either or. I've never seen them applied together because they essentially accomplish the same task. They just take different approaches and have slightly different results, but you have to focus on only one. So we would apply lemmatization. So in that, we would only take the root word, and the model will, at this point, only have the broken down sentence. It will have what it thinks it can assign weights to. It will get rid of any endings on their verbs, and then it will have everything simplified down into its bare bones words. So stop words is the it, then, a, and, any of those I had mentioned before. It'll get rid of any of those separators between sentences. And then we have dependency parsing. It will get rid of anything that it considers unnecessary. This includes so it's basically all of these different processes work together. You'll notice a lot of these sound very similar. And that's because the model will do everything it can to simplify it, except we have to apply multiple steps, even if a lot of them may apply to the same things. So it would get rid of one thing, and let's say another part, let's say we do our parts of speech tagging and then our dependency parsing. It may get rid of the same words, but we need to make sure we catch it in either step. So a lot of these may seem similar. You'll see how this works in the model. I will go over this more. And then noun phrases, it'll identify the subject. It will go, okay, so this is what the person's talking about. This is what I should be focusing on, and so forth. And then we have named entity recognition. As I mentioned before, it's NER, excuse me, and it will identify organizations, names, etc. And then co-reference resolution, it will have our solution. So as of right now, we only have our process text. This is not an actual vector yet of zeros and ones because we haven't applied that yet. Co-reference resolution would be converting this simplified text that's almost indecipherable to you into numbers now, because the model goes, okay, so this is easy enough for me to read to turn into numbers. So that would be this part. It's the resolution, and it will lead to data structures representing parsed text. So the ending is basically taking it, and let's say you want to make a motion analysis with NLPs. It would take this pre-processed text that occurred over here, and then it will convert it into a vector. It could read, assign weights to each of those, and then it would go, okay, so which weights are the most common for each of these inputs in our data set? And it will go, okay, so let's say it will assign weights that are higher for depressed text and weights that are lower for non-depressed text. So it'll go, okay, I'll process this text. If the weights are higher, then it's depressed. If it's not, it's non-depressed. And that's essentially our co-reference resolution, getting our answer for how can we classify depressed and non-depressed text in natural language. Okay, so is that pretty solid? Is that clear on how all of these different processes work? Let me see if I could exit out of here and go to Zoom. I want to make sure I can see the chat. So the program just traverses through the words in a sentence and determines. Yeah, essentially. Yeah, so it'll go ahead and think of it as a loop. So it'll go through each of these pieces of the sentence and go, okay, so here's my subject. So let's say my subject is, like we had mentioned before, chicken nugget. It will focus on that certain word. It'll go, okay, so what are we saying about that? And then it'll go, what are we doing with that? And it will only take our special words. It will ignore words that are like things that connect sentences, any transitions, therefore, and furthermore, in addition, because you don't really need that in a sentence to understand what's going on. And that's just very important to recognize, that your model will not take the least important parts, because if it did that, your model will take too long to train. It already takes hours to train some of these models, and you need to make sure you're only taking the most important parts. So I have another question. So between co-reference, resolution, and tokenization, don't they achieve the same thing? So tokenization is dividing these, so let me go over this really clearly. I didn't go over it very well. So your sentence, so let's say we have a sentence like, I have a computer. Tokenization will split these into, it would have been a string in an array, and it would become I, comma, have a, like, comma, a, comma, computer, right? So separate each of these words, and it prepares it to assign vectors and weights to it in the future. So it would split it and get it ready to go into co-reference resolution. And then in co-reference resolution is actually doing the assigning. Sorry if I worded that funky. Except essentially all of your pre-processing is not your weights yet, but preparing it for your weights. So it gets ready to assign your weights, if that makes sense. I hope that's clear. So is that good on all of those different points? I want to make sure that's okay. Yeah. Pre-processing does not involve assigning weights directly. We're preparing it to assign weights. I must have worded it funky. Sometimes I make a couple mistakes. Okay. So I'm gonna go ahead and move into the program. So we're gonna work on pre-processing text. So I will send a link, and we are going to be using pre-processing text underscore questions. Let me go ahead and open it right now. Okay. Yeah. So essentially, we're gonna be taking a couple sentences and breaking them down so you can really see how this is being performed. Let me grab my shareable link and copy. Okay, that should work. Go ahead and click on it, and I have instructions on the side. I'll go ahead and show you what I mean. So that should have worked. Please tell me if that doesn't. So over here, you will be directed to this page, and you'll notice there's a lot of code on here. Don't worry about that yet. And you'll go File, and you'll go ahead and click Save a Copy in Drive. I already have a copy right here, and basically, I don't want you guys editing this document. I believe I only have it on like View, but go ahead and save a copy in Drive. It should open. If it doesn't, just go into your Drive and click on like My Recents, and it should pull it up. Just tell me when you guys have that done. You could put it in chat like all good, or you could just say it out loud. I'll give that a couple minutes. Okay. Okay, so I think I'm gonna go ahead and move on. Please message me if there's an issue opening it. I will gladly just like help you through that. So we're gonna go ahead and import NLTK below. I'm going to do the first question, and I want you guys to try the rest on your own. I will give you like 5-ish minutes to try it, and then I'll go over the solutions with you guys. So over here, it says go ahead and import NLTK. So NLTK is our natural language toolkit. Think of it like your little tool on the side of your belt where you go, okay, I'm gonna process this text. And it will essentially categorize the text, analyze linguistic structures, and a subsection, like a sub-library of NLTK is punct. I'm just gonna call it punct. I'm not if it's punct, but it's a sentence tokenizer. It's part of breaking that sentence down into what I had mentioned, like taking the array, separating it down into the individual words so we can process it. So in order to import NLTK, we're gonna type import NLTK. It's pretty straightforward. So we're gonna go ahead and run that, make sure it works, and it should be good. This is quite a big data set for NLTK because we had to import stop words. And if you guys can message in the chat, what are stop words? You could put an example of a stop word or just explain what it is. Yeah, I'm seeing words to ignore. That's a great description for stop words. Yeah, a and the, yeah, exactly. So common words that don't bring any importance or meaning to the sentence, exactly. Yeah, that's great. Okay, you guys are really got this down. So yeah, it'll be words and anything that it goes, okay, I don't really need that and I don't need to include that in my text. So if they were included in training, what would happen? So think of when you're processing text, how do you make sure that all of this text is having the same structure? So everyone who's going to write out their sentence is going to write it out slightly differently, right? So I would write out my sentence differently from a non-native English speaker or someone who's from the South. You see what I'm saying? So you want to break it down into the sentence that is only the most important parts, because otherwise you may have higher error because everyone structures their sentences differently. And you really want all of these sentences to have about the same format so the model can see it all in the same light. And another thing is your model will take a really long time to train. So let's say I don't get rid of it and the. And by the way, these libraries get rid of about 50 different stop words. I'm only naming like 4 or so every single time. But these libraries have a bunch of stop words that they get rid of and make your data a lot easier to process for your model. Essentially, think of this like noise. It's like how when you're processing an image, you only want the most important parts. And I'm not sure if you guys attended the CNN workshop. I think we had done one before, except it'll compress the image into only the most important points. And that's similar to every process in machine learning is about the same, if you think about it. Images will be compressed into the most simple form. Language will be compressed into only the most simple form. So it makes it very fast to process. Some of these train in under seconds. It really depends on what your model looks like and how it's like tackling this kind of problem, because language can either be very lengthy or very short. It depends on how you build it. But I hope that answers that question. So basically, more errors, and it'll take a lot longer. And okay, so this just worked right here, as you can see. And we'll import NLTK. I don't know if this is large enough. I'll go ahead and make that bigger. So we imported our natural language toolkit, and I'll let you guys go through the rest of this. You'll see it here. I'll ask you to import Porter Stemmer from NLTK. Don't focus on Porter when you're trying to figure out what this does. Think about, what did I say stemming was? What would this probably do? I'm gonna ask you a question. What do you think this library does, being that the word stemming is in that word? And I just want you to look at this whole thing, and I'm gonna have you add a contraction in there, and I think that's about it. I don't think I do another one. But anyways, so you could go ahead and start that right now. And I'll go ahead and check back in about like 5 minutes. I'll give until 38 after. Also, when you guys finish, just put a thing in the chat, or if you have any questions and you're really confused, you could also send me something in the chat for that. So when I go over it, I make sure I explain that. Don't worry about the specifics of like, what's FTFY, why are we importing this, why are we importing that? Just try to get the code to run properly, and just take a glance at it so you know what's going on. Was that dictionary with contractions hard-coded? Yes. So I had done a project recently, and we went ahead and we hard-coded them. I'll, Stemming is to reduce words to the root word. Yeah. Yeah. I want you guys to read through it, and I think I actually put some of the answers in there. So it'll be very easy to. I'll go over that. I'll go over that. I think I worded it slightly different. I meant I said root word as in the base word. Both of them, if you look it up, technically simplified down into the root word, both stemming and lemmatization. They just perform this process differently. Oh, I keep losing my presentation. Let me see. Also, when you guys finish up, make sure you just send a message in the chat so I get an idea of where you guys are right now. I'll save that right there. Where do we end? So you should only import this Porter stemmer, and you should have one contraction. I think that's everything. It will be in all case if I added something where I want you to add, like a sentence or code. Yeah, that's all. So as soon as you do those 3 things, you're done. So go ahead and just like put a message in the chat, and I'll go over how like all of this works. Like, why did I put it together this way, and why did I format it this way? We have 2 people done. Okay. Okay, cool. So we have about like 4 people done. I'll go ahead and I'll start. So let's go over this real quick. And I'm going to pull this up. Let me see. So I already went over the beginning. So stop words were it, the, and, etc. And FTFY stands for fixes text for you. And so let's say we have someone on the internet. Let's say we're pulling from Twitter. something like that, pulling from Reddit, Instagram, there would be those people who either punch their text in like this on those social media platforms on purpose, like let's say as a joke. And the model will go ahead and, let's say we pull data from Twitter and we see this kind of thing, the model will have no clue what's going on. So FTFY attempts to fix things like this. It will never be perfect because you can't really decipher a lot of this stuff. It's just about trying to make it all processed in the same way. So that's essentially what FTFY is doing. And we have to run these because in Google Colab, it's just weird. I hope you guys know what pip is. If you don't, pip is essentially something that can install Python libraries. And FTFY and stopwords isn't pre-installed on Google Colab, so we have to go ahead and do that. It will say that it's already installed FTFY and stopwords. And so we're going to take Porter Stemmer from NLTK. So based off of this name, what do you think Porter Stemmer does? Especially based off of the presentation. So what does, stemming. So what is stemming exactly? So let me go into the presentation. Yeah. So I want to show you guys the example again. So you guys are exactly correct. It's cutting off things like ing and etc., except it's cutting them off into words that you don't really know. So chang isn't a word, like for a verb, and change is a word. Stemming, these both turn them into their root words. These are both root words, but stemming doesn't exist. Lemmatization does exist. So let me think of this. I'm trying to think of an acronym to like remember this. Stemming for doesn't exist. SDR. Yeah, I can't come up with anything on the spot. But just remember, stemming is it doesn't exist. Lemmatization does exist. It has to exist in the English vocabulary for you to take the lemmatized version of your text. So removing parts of the word to get close to the root word, but it can be a word that doesn't exist. Exactly. So you guys got that down pretty darn good. And that's essentially why we're importing Porter Stemmer. This is a library that can perform exactly that and can stem words. So yeah, stemming could possibly not be a word. So yeah, I'll essentially just condense it down so the model can read it. And we'll import Porter Stemmer from NLTK here. So we'll go from NLTK, import Porter Stemmer. I believe that's right. I don't want to make any errors while I'm doing this. Porter Stemmer. And we'll go ahead and play that. And it goes, okay, all changes saved. That means it worked. So basically up here, you'll notice a lot of these libraries seem very arbitrary. Don't worry about memorizing each of them. A lot of these are actually case sensitive. So if you type them in slightly wrong, it won't recognize them. So always feel free to just give a quick search on Stack Overflow or just a quick search on NLTK's documentation in general. I encourage reading documentation. You need to get in the habit of that because machine learning models aren't always described for you. Like you'll go ahead and go, okay, I want to make something that can analyze emotion. And you'll go online and there'll be no answers sometimes. So you have to make sure you can understand the documentation of these libraries because if I had no way of knowing how to use Porter Stemmer, like let's say I had no sample code, but I did have documentation of the library, which exists for a lot of these, I would be able to read it and understand, okay, so Porter Stemmer comes from NLTK and it performs stemming. That's similar to scikit-learn. It's scikit-learn's just used in a lot of machine learning models, neural networks, and we'll take our metrics and metrics as in it will do your accuracies and stuff and it'll go, okay, so let me do a classification report, an accuracy score will go, here's how accurate my model is. And that's essentially what this library is doing. And this one Gensim. I'm not sure I don't know how to pronounce a lot of these. It's all code. You don't have to worry about saying it while you're coding. But so from gensim.models, you import keyed vectors. So keyed vectors are essentially ways of classifying your text. I had mentioned weights. And when separating your text down into the simple sentences and simple words, a vector is what's assigned to each of those words, and it turns it into a binary array that wouldn't have been possible without this. In this project, I do not believe we're going to be using these directly though, like keyed vectors. I don't think so. Like, we're not going to be using TensorFlow or TensorFlow for sequential. That's for deep learning. I just included these because I want you guys to have that exposure. See what kind of like libraries you're going to have to use when you do NLP. So you'll commonly see TensorFlow, Keras. You'll see a lot of NumPy, Pandas, Matplotlib. You'll see so many of these libraries. I want you to look at it now and go, okay, so when I see this, I'm thinking of machine learning and NLPs, and especially deep learning. You'll see a lot of this in deep learning where it's breaking down your information into separate layers. It could process it. It goes, okay, so let me set this to a certain set of my data set, and it can process it with a lot of these libraries. I will not, as I mentioned before, I will not be going over this as deeply because we're just going to be doing pre-processing for this part of the code. So that's essentially what these are. Don't worry too much about these. You can always just make use of them as you go through your code. So I personally went through making this project. I was like, okay, so I need to stem my words. So let me import NLTK. And that's essentially just how I went through the whole thing and do it step by step. Go, what do I need? How can I solve this? So NumPy is for making multi-dimensional arrays. A lot of your code will be in multi-dimensional arrays. Gosh, that's a mouthful. It'll be in the form of vectors or zeros and ones that the computer can completely understand. So NumPy is a really great library for machine learning. You will be using it repeatedly, no matter what you're doing, whether it be CNNs for image processing, NLP, NLPs for, let's say, processing text for depression, or if you're doing a recurring neural network, you'd probably be using this library too to process your text or your information in general into simple arrays that the computer can read. And Pandas creates data frames. A data frame is essentially just formatting your arrays so the computer can understand it. Think of it like NumPy has all of your data in a big, ugly chunk. Pandas goes, okay, let me format it. Let me put it into nice columns, nice rows. The computer can read it. It's super nice. And it makes everything super organized for you. So down here, you'll notice we import re. This is an extremely important library that I'm going to be talking about. I'll go down and I'll explain like when that's used. I can't remember if I clicked play on these. I'll go ahead because I was like just talking. So we're gonna go ahead and click play, and let's make sure all these are imported. So down here, I wanted you to import ain't, or if you could think of anything that wasn't on this list. I couldn't think of anything. I mean, it ranges from it to div. I don't know who would say that, but you gotta think of every possible contingency. And it also has heed or anything like that. So we're gonna go ahead and import ain't. Ain't becomes am not, I believe. And we're gonna encapsulate these by quotes. Make sure you do not delete this comma, it will ruin the whole thing because it's in the form of a dictionary right now. So it'd be ain't is am not, it follows the same structure of all of them. Let's click play on that. So it's imported, or it's created a variable called CList that can store all of these contractions. Someone asked, why did I hard code this? So in our project, this was actually a snippet of our code from a separate project, and we decided to hard code all of them so we could specify exactly what contractions we want to be processed. So essentially, we want to make sure we weren't missing anything. I'm not sure if there's a better library for this, except this is what we found to be the most beneficial, especially for things like o'clock, which may not be included in specific libraries. They'll normally only cover things like shouldn't have, or should have, you know, the basic ones. So we want to make sure we cover everything. So when the person says something, the computer's not going, oh, that's kind of weird compared to all of the other text. It's catching all of it. These were just pulled from online, and we just decided which contractions were most important. We just took all of them and went, okay, do all of these contractions and turn, if they say y'all'd, it will make it you all would in the text. So that's very important. It simplifies the text. You'll notice I keep saying simplify, condense, any of those words, because that's exactly what you're doing in NLPs, just making things smaller. So means regular expressions. So .compile allows for it to use a pattern as defined to do pattern matching. So someone had asked a little bit about They said, I can't find it right now. I believe it was something, oh, re.sub. So re.sub, let's see, what did I just say that? Re.sub will substitute these things. So you notice how it's very abstract things. You're like, why is this a bracket, a caret, 0, -9? You get what I'm saying? You're like, what the heck does this mean? And guess what? The computer is saying the exact same thing as you right now. So you have to consider, we do not want any of these things. So when it's subbing it, it means substitute this, any of these characters, any of them. It doesn't have to be together. It just goes, is there a parentheses? Is there a special character that it doesn't want? It will go ahead and substitute it to nothing. It will get rid of it in that text. So it will get rid of anything that's unnecessary, and it goes, gosh, I don't even know what this is supposed to mean. So let's say a person links an image in their text. On Twitter, you'll see that a lot, where someone links their image to, let's say, a funny video or a funny meme online, right? But our model doesn't need to be looking at these kinds of things. It needs to be looking at the text, not the image they decide to link. So it gets rid of that through these kinds of different pre-processing methods. Someone said, how did you learn about neural networks and NLP? Any courses or resources? Okay, so NLPs, I was actually just introduced to NLPs recently. I recommend sites like Medium or just YouTube. YouTube has amazing graphics for how they work, how does it break it down. Those are always amazing, and they're free, so that's cool. And just online articles, websites. At the very end of this little lesson, I will be giving you a link to a free course that's hosted by a prestigious university for machine learning. I encourage you guys to look at that. It's all free. So yeah, in general, for anything related to machine learning, I just recommend going online and doing a quick search, like, how do I do this? Let's say I go, how do I do stemming? And I go ahead and I look up that, you will get plenty of different answers. Especially on Stack Overflow, they simplify it down into only the most important parts rather than reading really complex text. I try to do that here, so it's not as complicated, but you'll see a lot of that online for you. I really recommend checking out online resources. So essentially, we're going to create an array called clean tweets, and for each tweet in our tweets, we are going to match these different special characters to the tweet. So does this tweet have any of these characters in the first place? And it'll go, okay, if there's none of these, forget it. We don't need to run any of this. So if it does equal, if it has these, it will go ahead and it'll take the tweet that's of a certain length. And because in this model that I created, we wanted to be greater than 10, because if our tweet was, let's say, 2 words, the model's not going to get anything out of that. You don't know if the person just put in a random couple words like, let's say, hi. The model's going to go, what are they trying to say? That's not important to our data at all, right? So we're only going to take the most important parts. You need to consider that when you're running your data sets, that you only take the most important pieces of text. So we're going to only take the ones that are long enough for the machine to understand, but condense it so it's short enough so the machine can parse it easily. So we're going to go ahead and after we split these, we're going to join it it by the spaces, and we will get rid of any of these special characters. And I'm just making this very simplified right now. It will basically split all of them based off of where that different special character is, and then it will join it at the end. So imagine it taking it apart, going shoop, and then taking all of those symbols, and then going, and it'll put the whole sentence back together. That's what that's doing. Down here, you'll notice we use FTFY. This is fixed text for you, right? Something like that. Except it will take your sentence and it will take any things that looks arbitrary. I'd mentioned it above. It was a really weird looking text where I'm like, I don't even know what that's saying, right? It will take this right here, you see it? It will take that and it will attempt to parse it. So all of that text is having some sort of pre-processing performed on it rather than going, let's just ignore that because I don't know what's going on. You have to address all concerns. So I'm gonna go ahead and run this for now. But yeah, so we'll go ahead and say T is equal to expand contractions. So we'll run expand contractions, which is defined down here, which is gonna turn anything like can't, won't, any of those into our base words. And we're gonna run that and we'll get the result from that. And we'll do a little more pre-processing down here. You'll notice that it does tokenization. It'll separate it down into the base words. It will add, it'll turn this array into the separate words that only needs. It will get rid of stop words over here. We usually have to specify our language for a lot of these types of models because they do up to 49, 59, 70 different languages. So we have to specify this is for English. You'll have to look at documentation to see when you should be defining that. I don't know this off the top of my head that I have to define English right here. This is something where you have to be reading the documentation as you're making the program. So we're gonna go ahead and assign our word tokens to the tokenized tweet as I mentioned. And the filtered sentence is, this is just a Lambda function. It's a loop in one sentence. And so W for W in word token, so in our tokenized tweet, if it's not in our stop words. So essentially take every word out of word tokens if there's not a stop word in it. So this is taking our whole sentence and going, okay, get rid of anything like is, the, it, anything like that. So this is our array of stop words. This is our true tweet that we parsed. And then this is getting rid of those stop words based off of our stop words list. So, and then we're gonna go ahead and join any spaces that are like making it hard for the computer to read it. Let's say you have multiple spaces, like, oh my God, why are these so spaced out? Because we just did all this pre-processing. We have to make sure it's read like a regular sentence. And it's not, has double spaces or anything weird like that. We may encounter issues where it can't fix that, but I will go over that later. I'll have to see at the very end, we'll be inputting some sample text into it and see if it has that issue. And we'll finish by doing Porter stemmer, stemming our words, and this is our clean tweet. So that's our full tweet. You notice how it called expand contractions? It will start running this. And it will similarly get rid of any sort of hyperlink. And it's the same gist. It will get rid of it if it's not the right link. It will get rid of any special characters. This is performed twice to make sure it doesn't miss anything. And FTFY is performed, and these can, I'm pretty sure these could be run separately. Like this one in our machine learning model is being run separately at one point. So we could process different text different sorts of ways. So this is a different way of approaching this. And it will do essentially the same thing. For English, it will get rid of stop words, filter a sentence, use Porter stemmer, clean our tweets. And okay, so we're gonna go ahead and run that. I believe I already ran the last one. So that concludes that program. So we got rid of anything that was special, anything that was unneeded, joined them, and now we can run this. So let's try and run this. So today's been pretty darn cool. I know I have a very wide vocabulary. And then I said, I mean, I tried to use different contractions to make sure this was working. Been better. And then I just put a random hyperlink. This would be a sample of a hyperlink. and it transformed into today, pretty darned cool, mean, could, better, HTTPS image com. So you notice how it didn't get rid of this? This might be an issue you would have to tackle in the future if you feel like this is causing an error or a lack of accuracy in your code. For now, I think it's important to just leave it as be. I did this to keep this simple, because this would include a whole other sentence of, or a whole other line of just pre-processing, making sure we get different domains specified. Like if, let's say we wanted to get rid of anything that's related to Twitter, images, or and so forth, like we had done before. We got rid of anything related to Twitter because we were pulling from Twitter. We didn't do it for HTTPS. And you notice how this says ED? Sometimes you will get those issues. None of this is 100%. Just because Porter Stemmer is running doesn't mean it will catch everything, especially when text is weird. You have to think about it being in terms of darned. Is that a common word? Do you think Porter Stemmer would catch that? You have to think about that when you're making your model. Your model will not understand everything you're saying. In fact, a lot of slang will not be picked up. So that's very important to consider, especially when you're pulling from social media. So it did not pick up on darned. I just want to make sure you're aware of that. And someone said, what was the aim of your depression-related NLP project? What are some common uses of NLP in the real world? Oh my gosh. So I actually presented the other day this NLP project. This is just a code snippet, as I had explained before. And what we had done is we created an app, a working app, where a person could register through Twitter, and it would analyze their tweets that were posted on their account or that they tweeted or retweeted, and it would process it. It would do this exact process. This is exactly what we used. We pre-processed it, and then we used it as CNN, a convolutional neural network model, to turn it into different layers that the model could understand. And we used a certain number of epochs and batches, and it had an accuracy of 95%. So it could accurately identify depression in text, and it was super neat. I loved working on that project. We had about 20,000 different pieces of data. You notice how it's a very high number. You have to have that many pieces of data when you're doing NLPs. So that was super exciting. I really encourage you guys to look at open source on GitHub if you want examples of NLPs, or if you want to just go online, search up these projects. There's quite a few of them out there. They may not accomplish exactly what you want, but there are examples that you can work off of and build off of. So yeah, that was super fun for me to be working on. You could input anything you want in here. Let me think of something. What can I input? So, ain't today a great day? So I made sure to use a contraction. It says, ain't today a great day? So you'll notice it probably turned it into ain because I think Porter Stemmer took part in that. It may have taken part in that. None of this is perfect. I'm trying to emphasize that to you guys right now. None of this is perfect. But if it's enough for the model to achieve your accuracy, that's okay. You need to make sure what you do normally when you create these NLP models, or even any model of any sort, you will do your pre-processing, your dense layers if you're doing a deep learning model, and then you will see your results and then go, how can I fix this? Because you shouldn't be worrying about every tiny detail until you see your results. I will go over how to analyze results in the last 27 minutes. I hope to be able to get through the last project. I thought it was so cool. I really wanted you guys to see it. So I'll go ahead and quickly go back over to the presentation. That was that project. I had a lot of fun making that, and I hope you guys did too. So let's look at some common libraries. I already mentioned these. I will go over it very briefly. So NLTK, Natural Language Toolkit, break down your sentences, linguistic analysis. We saw how it could use Porter Stemmer and essentially break it down into the important parts of your text. And then we had sklearn, or scikit-learn, my bad. And it's great for regression and clustering. So essentially whenever you're processing your data and you need to separate it down into these different layers of analyzing your data sets. And they support vector machines. So essentially taking that long array of zeros and ones and turning it into actual answers and percentages of what's the probability that this text has this certain category associated with it. Let's say we have categories associated for the news. Is this associated as a hazard? Is this associated as an event? You get what I'm saying? So NLPs could be used in so many different things in the real world. You commonly see NLPs in, what else? Like I mentioned, you'll see some of it, you could do it for news. I love the idea of identifying fake news. So recently there's been a lot more projects of figuring out when something's fake. So how do we know when someone's lying through, let's say Fox News or something very important? There's so many people who could be deceived, but what if a machine could pick up on this when a person couldn't? That could be kind of performed through the next model I'm going to be helping you guys build. It's a fact identifier, and if you could have something that fact checks all of your news, it would essentially be able to identify fake news, and that's super cool. So the last one is TensorFlow. This is just generally used in machine learning and neural networks in general, and I just want you guys to have an idea of what it is. So if you're ever like asked, oh, do you know what TensorFlow is, or Keras, you go, oh yeah, like it's used in deep learning neural networks. Like have that idea. Go, okay, so I got this circulating in my brain, even though I haven't used it just yet, or maybe you've used it in the past, maybe in one of these workshops. Just have it in your mind, like what this is. So computers can officially care about you. Kind of ish, if you think about it. Computers can identify emotions, and they can classify text. Another application would be in Gmail. Identify spam mail. This is a little blurry. I couldn't find a really good example, but you can tell by yourself, like this is probably spam, right? So we can look at this and go, okay, so this is not something we want to be seeing. Let's put that in our spam. So the computer breaks this down, and maybe it says, maybe when this email has multiple links at the bottom, it will get rid of it. And it'll go, okay, that's most likely spam because they're giving them a bunch of links. Or let's say they're using a bunch of caps like this and special characters that look weird in it. No one would normally form it dollar, $1,000. It looks weird, right? So the model will be able to pick up on that if you give it enough samples. There's plenty of data sets out there, by the way, if you ever want to check it out. Check out Kaggle, or just search it up online, like spam data sets, any of those. You can normally find code on it too that you could read about. So this goes into emotion classification. They usually have been done for like identifying when something's 1 star versus 5 stars, you know, like when you're rating a movie, an Amazon product, any of those. And I have a funny little example at the bottom. I want to include some other ones, but that was just one of them. They're really funny. You can look them up if you ever want to. So essentially it would look at words like loved. It would look at easily or efficiently, and it would go, okay, so that's probably 5 stars. And then it would go, okay, so 1 star, it's horrible, broken, missing. You see, it takes those keywords, it'll go, okay, so that means it's really bad. Let's identify that. So yeah, that's essentially like identifying emotion or how someone feels about something, and that's really cool in my opinion. I'm gonna go ahead and move on. So importance of a large data set. So I explained before how I used 20,000 different samples for my previous NLP. Your model is like your child, and it's a very quick learner, give or take. And you must feed it information. So you need to make sure you have extremely large data sets, whether it be scraping from different social media sites and ensuring, normally you have to manually screen this data and make sure it follows a certain criteria. Let's say for my depression data set, I made sure in our group, we had a 20,000 set of like samples, right? And we briefed all of them to make sure they all made sense. This took a long time, but it was worth it because it was worth the accuracy of 95%. It's super cool. So I believe this has been covered before in the previous sessions. I'll go ahead and brief it. So you have 80% training, 20% testing. You want your training to be greater than your testing. And you can have validation. So validation is important for ensuring your data is not biased. And you go, okay, so this model's it's never been exposed to this data before. Let me throw this at them, like at the model, and see if it can understand it. And that's the whole point of validation. Normally it's a small subsection of your set, just like testing. keep in mind that all of these can change. All of these different numbers can change. And you can make it whatever you think is most appropriate. So as I had mentioned, you can use Kaggle for data sets. It's really cool. They have a community of computer scientists on there who work in machine learning. And models love CSV files. So you can read a CSV with pandas.read_CSV. I mentioned before how you can use pandas to process your information. It basically can create a data frame, so pandas.dataFrame, and it will make it into a row and column, basically like a table, but for your program that the computer can read. And so ML can write your notes. This is gonna be really fast. Look at it quick. So it essentially highlights the most important parts, and then it lists the facts on the side. You see it? I want to make sure you guys see that. It went by really fast. I hate this because it's just a GIF. It doesn't look like it. Okay, yeah. So founded by the Romans, it will pull that out, and it'll go, okay, so that's the most important based off of the subject. So it will go, okay, so I'm looking for anything related to London, and it will go, okay, so it was founded, it as in the subject London, it will identify that, founded by the Romans. So it could do that. And that's super cool. What if you just had this like listen to all your classes and it just took your notes for you? See, it has all sorts of applications. And I'm gonna have you create another NLP model. It's really cool. I'm gonna have you make a fact identifier. It's gonna be really quick. It should be pretty quick. I think I'm gonna do this one with you. So create a duplicate of the file. Let me go ahead and link you guys that one. I really wanted you guys to have a lot of exposure to all of these. I want you to see a lot and gain a passion to really go ahead and do this outside of just this session, this tiny session. Let me go ahead and grab this link. Copy. Oops, let me change that. Anyone with this link can view. Okay, so I just put that in the chat. We're gonna have to go through this quick. I only got 18 minutes. There should be enough time to cover the bare minimum of this. I really want to show you guys this project. Like I want you guys to have exposure to just the pre-processing, because that's one of the most important parts. It will take you the longest to do the pre-processing normally in your NLPs. So I want you guys to really see that and understand how that's working. So just tell me when you guys got that down. I will give that a couple minutes. Let's see. Tell me if that's not working also. I think it should be working, but just tell me. I'm pretty sure that's set up right. Anyone with the link can view. Okay. So I'll do a couple more seconds, and I'll wait until like maybe 2 more of you guys got it down. And I also wanted to specify that I do not want to take credit for this code right here. This is, I referenced mainly a Medium account. The other one, written purely by my team and I. And this one was actually, I pulled most of this information from Medium. This is why I recommend it. It will come up. You know what, let me try and find it right now, the link, while I wait for you guys. So Medium, NLP. Yeah, if you just look it up, it will come right up. It's really cool. I just wanted you guys to really see this project. It's super neat. So, let me see. I just linked that. So I just linked that. You can see the whole Medium post. It actually goes really into depth on how this works. I'm just briefly going over this. So while that's working, I'm gonna go ahead and go over this code. I'm gonna do it with you guys. So we're gonna go ahead and do pip install as I explained. It imports a library and it's gonna import TextAC. It's just for processing the text. It will be a very big library. It's very extensive. And while I wait on that, let me see. Yeah, let me go ahead and type this in. So let's import Spacey. I can't remember if this is capitalized. I don't believe it is. It's not capitalized. So let me see. Is that done? Okay, that's done. So in here, we're gonna go ahead and import Spacey on here. Let me see. I don't want to write this wrong because it might crash. So import Spacey. Yeah, there's no caps. Import textstacy.extract, and we'll go ahead and run that. And it's good. So just tell me if I'm going too fast, by the way. I want to make sure I get this in. We're going to grab our data set. And Spacey is basically, it's good for word vectors. As I mentioned before, this assigns weights. And it essentially like figures out which words it should be like focusing on in terms of parsing it to turn it into digits, from words to digits. That's what Spacey is doing, or Spacey. So it's really fast. It does the NER as in terms of recognizing names, organizations, etc. Let me click out there, my bad. And it's really robust. It supports a lot of languages. TextStacy is built on this library right here. It does part of speech tagging, and it has dependency parsing and tokenization. Yeah, so essentially it's breaking down the sentence into simplified versions. And this one's going ahead and turning it into the numbers that our project needs to read. So think of this as the beginning and turning it into the simplified words. This is our numbers. So we're going to go ahead and import our data set. This might take a little bit. And I think it's like, I don't remember how big this file is. It might be like some form of megabytes, except all this could be done online. That's the cool thing about Google Colab. It will pull these data sets from online if you get it the right way. Some of them you have to actually use a CSV from your computer, and you would have to import it. Oh, it's 800 megabytes? Okay, cool. Yeah, so I'm about halfway right now. Oh my god. Okay, so I'm gonna go ahead and move down and start explaining. So we're gonna create natural language process. It's just a variable. We're gonna use Spacey, and we're gonna load our data set. So let's go ahead and use the name of our data set. Our data set is called n_core_web_lg. So this should be done in just a moment, if it's 800 approximately. Okay, it should be good. Yeah, so I'm gonna go ahead and skip over that for a second. I'll go back and run this. So essentially we're gonna define our text. So I just had a sample text of facts. This is the sample that you saw in the presentation where it said London is this, London was founded, and etc. I just have this example, and it will apply this NLP with our data set to our text. Is this ready yet? Oh my gosh, I want to go faster than this. Let me see. So it's gonna make that equal to a variable called doc, and it will do a new variable called statements. It will do TextStacy, that library I was talking about. Let me scroll back up so you know what I'm referring to. It's this part of speech tagging. It will take our data set and it will simplify our words, and it will extract, and it will take our semi-structured statements. So technically, like, just simplify my statements down to their basic parts. And it will take our doc, which is all of our words, and that's all of this, and all of these facts up here. And then it will say, look for anything related to London. And that's still loading, gosh. If it loads on yours, just click play on all of these. It should go through. And down here, so let's see what our computer knows. We'll print out, here are the things that I know about London. This is just a basic print statement. And for each statement in our statement, so this is an array, we'll print out our subject, our verb, and our fact, and that's going to be equivalent to our statement. And that's just everything that's composed of this one thing. And we only want our fact. You could pull out subject and verb, but we're gonna focus on like what are our results right here. And we'll pull out fact and we'll format it specifically, and it will print out your facts. I already have my results right here. This is what it will print out. I don't know if this is gonna load anytime soon. Oh, I think that's good. So we're gonna go ahead and click that. Oh, so can't find NCore, doesn't seem to be a shortcut link. So invalid path or file. So let me see. So this, you will run into all sorts of errors. Let me see why this is happening. NCore_web_LG. Okay, let me see. Maybe I didn't run one of these things up here. Tell me if it's working for you guys, because I might have just missed clicking play on one of these, honestly. Let's make sure. Should be, mine has the same error. Let me see. Let me see. Can't find, it doesn't have a shortcut link, or it's an invalid package. This was working beforehand. Let me see. I played it like a minute ago. Okay, so let me try and search this on Stack Overflow then. So let me search it on Stack Overflow. Oh, I'd already clicked on this, gosh. Oh, I forgot to click play on that or something. So Python-m spacey download. Oh, okay. I'm gonna reset my variables. I think, here, let me actually try to play this. I just want to get this working so you guys can see it in action. Let me see, maybe that's the way I need to do it. Yeah, my apologies for this. I didn't realize this wouldn't work. I had ran it a minute ago. Yeah, let me reset my variables. So I'm gonna go ahead and let me see, runtime, and we're gonna let's restart runtime. Yes, and I'm gonna go to the top. I'm gonna install that again. I'm gonna click play on that. I guess I didn't click play on this. Did I? Okay. This looks like it's loading. I guess I'll have to wait to see what the it results in. Okay. Oh shoot. London. And doesn't know what doc is. Oh. Okay. So. Right. Okay, my bad. I'm so sorry, guys. So before that, I'm just gonna go over what I did. You notice how I debugged that and I went through Stack Overflow and I figured out what the error was? That's super important because even that was completely unplanned. So you have to click runtime, reset your runtime so it gets rid of all of your stored variables. One, what that means, it tried to run this data set, but it goes, I don't even know what that data set really is. So we have to make sure. You notice how on Stack Overflow, it said you have to, if only I could get to there, it said you have to run this function. It says it doesn't exist without this function being run. So we're gonna go up here, and I'm pretty sure I defined it. I think it was that it hadn't kept it in its local variables. So you need to make sure you run this, and then you run this, and it will load your data set, and then it will run your text. It must have been something to do with the runtime, and we just had to reset our variables. Sometimes that's necessary, especially in Google Colab. This is not my preferred IDE. I don't even know if this is really an IDE. It's just something to process your machine learning code. Except tell me if you have that figured out. If you don't, just try, you could always like email me after. I'll leave my email at the end. Except just restart your runtime, do everything from start to finish. It should run. And your data set should already be loaded, so it shouldn't take a long time. So that should fix it. My apologies for that again, gosh. So yeah, it'll go ahead and print out your facts. And the facts were the capital and most populous city of England and the United Kingdom. A major settlement for 2 millennia is all of our facts about London. So we could also change our facts. So let's say let me think of some. Is dumb and gross. Let me see if that does anything. This is just about testing our project out because it's just about seeing what we could do with it. So it didn't catch the keyword London, so London is dumb and gross. Let me see. Let me try that. Let's run that. And okay, cool. So you can input anything, and it will go, okay, I'm searching for this keyword London, and it will say it is dumb and gross, right? So it goes, here are the things I know about London. It's dumb and gross, right? So it just took the most important parts. Also, send a message if you guys have that issue figured out. I don't know why I did that all of a sudden. It must have been like the way I had exported it or something into Google Colab, except resetting the variable should work for that. Just send me a message when you have that fixed. Okay, cool. Yeah, it worked. So yeah, my apologies. You'll have all sorts of issues when you do machine learning. Gosh, I expected this to work pretty easily though. My bad. So essentially it's gonna just output whatever your results are. You can try whatever outputs you want. And the important thing you notice here though is that I can put anything in here and the computer considers it a fact. It's like, think of your computer as something super gullible. Like your computer will believe anything you say, right? So imagine if all of this was fake. Like London is not dumb and gross. I'm not gonna insult anyone who's from London. If you're from London, I don't know if you are, but I do not mean this. London's great. But what you have to consider is if you give your data set, if your data set is not right, let's say you have a poor data set that has prejudice in it, or if it's, let's say it's inaccurate in any way possible, your model will believe anything you give it. So it will say whatever it's seen. So you have to make sure your pre-processed data is good enough so when you give it to your model, it will understand the text, not only on a conceptual basis, but on the fact that you have to make sure this data is actually correct. That's why we had, personally for our project, we had to manually screen all of our data to make sure we weren't passing things that were wrong into our model. So that should have fixed this issue. Tell me if I can move on. Please, like, just notify me, because I want to get to the very last part. Okay. So I'll wait like a minute or so. I just want you guys to see one thing in the presentation. Yeah, this took a lot longer than I expected. Okay, cool. So at the very end though, I want to go over how to understand your accuracies and such. I might go over by like 5 minutes or so. Yeah, I really like this project too. I would recommend just tinker with this project. You could always do more with this. You can turn it into a bigger program and so forth. For now, I have the answers in a drive. I will go ahead and link that so you guys have a hold of it. Let me go ahead and do that right now. So this is, let me see, so we're gonna share that. Copy, oops, let me change that to only 0. So this is the link for the first project, the answers, if you did not catch that. And here are my answers for the current model. Let me grab that. Let me change that and make it view. Okay, cool. So, oops, I accidentally sent it to only one person. Okay, wait. Let me change that. So, let me grab that again. Okay, cool. So, yeah, my apologies. I only sent it to one person. So that's the first project. Oh no. Wait. And then that's the second one. Oh my gosh. Wait. Okay, yeah. Okay, that's good. So I thought I didn't activate the video for a second, but I forgot that you did. Oh gosh, that's so bad. My apologies for that. But so I'm gonna assume everyone's about ready to go on with the project. I just want to go over this real quick. So, so I guess computers might take over the world. Not really. They're a little bit inaccurate. If you use any kind of slang, for example, army is equivalent to gravy. In Cockney rhyming slang, let's say someone talks like that online, the computer will not know what you're talking about. And this is important to recognize, so you might have to consider different slangs different slang, any way a person might type text online. So when should we trade off speed for accuracy? So normally your text classifiers will be fairly fast. You'll have classifiers like naive Bayes classifier. I recommend doing more research on this. It includes more to with probabilities. It's super cool. I really recommend looking at this. There's great Medium articles out on there about naive Bayes. So you can have really fast ones like naive Bayes, or you can have CNNs like convolutional neural networks that are very slow in training because they use multiple epochs and batches. I'm gonna go ahead and go pretty fast with this. So understanding your results, essentially you want these numbers to be higher. Your precision is essentially, think of a target, how close your data points are together. Accuracy is that it's actually in the middle of the target, right? So accuracy is towards the middle, precision is the points are next to each other. So loss over here is also described. It's described in your F1 score. It's normally given in your results, and it's essentially whenever your model identifies something and goes, oh wait, that wasn't right. So it's a false positive or a false negative. So it identified it as positive, although the answer was negative, or vice versa. So basically, your F1 score is how many times your model was wrong, right? And then your support is your support vector machine. Support vector machine just means this model was given a data set and it determined our answers, right? So this is not something that's unsupervised. This is supervised. So this whole thing was given the data set, it's told what to do, and so forth. So this is a support vector machine. Linear regression is an example of a support vector machine. It's very simple, it's easy to do. And these are just graphs of our epochs, which is used in deep learning, versus our accuracy. So as we increase the number of groups that we're testing our data sets, the accuracy goes higher. And you notice how it will level out with time. So that's just part of training your model and making sure you get the highest accuracy possible. And you normally can output these with matplotlib. I recommend looking into matplotlib. I mentioned in the beginning. This is all done in matplotlib. You can do that exactly through your model, and it will output this. It's super cool. Let me see. So I want to cover this. Please take this part in. Take this part in. We have to consider bias. So computers will pick up on anything you show it. I had mentioned this before. They're very gullible. And training a network on a poor database leads to horrible results. You can have outdated database, prejudiced database. In this case, this database was actually racist. This was for Microsoft and other popular companies like IBM. And they did not have enough samples for people of color. So when they tried to identify people's faces, it had more trouble identifying people who are, let's say, Latinx or Black and so forth, right? It had an extremely high accuracy for someone who was white. And you don't want that in your data set. You want your data set to be unbiased and it covers everything that could go wrong and every contingency that it will be presented with. This data set is important to consider. You can't have it be outdated. Let's say it was from, I don't know, 1995. That's too outdated in my opinion. Even 2004-ish. So you want an equal amount of data for all categories to minimize bias. Yes, you have to, let's say I'm training a data set for a bank. And it goes, when will this person leave the bank? Like, let's predict when they're gonna leave the bank so I can see who I should loan my money out to. Isn't that so cool? People do that. So you need to make sure you have both women and men, because if you only calculate for men, you've not only embraced an idea that men can only be part of the bank, but also that the computer will not know how to identify whether a woman is gonna leave the bank. That's the kind of things that will come up in your models that you have to address. It will essentially ruin your results because it will not understand so many things because you did not show it. So yeah, in old data sets, you'll commonly see things are mislabeled. I'm in a group for machine learning and data science, and one of them, an adult was talking about how she created a machine learning model, and they were identifying pictures. And they used an old data set from the 20th century, right? So it was from 1990s-ish, right? But it was outdated in terms of its terminology. So someone who was in a wheelchair was not identified as someone who was in a wheelchair, but they were identified as someone who was, this is exactly what I identified it as. I need you to understand this. It identified them as someone who is a loser. You see the issue in this. If the model identifies the person and actually gives that label to that person, it will inaccurately do so many different things. So you need up-to-date data sets that don't have bias, that don't have prejudice, and that you recognize all of your limitations within your data set, because every single project will have problems. You have to address them as much as you can. That's why you never have 100% accuracy. So I'm running a little bit over, but I'm gonna go ahead and conclude with always pursue more knowledge. Throughout this presentation, I've just been trying to encourage you, go forward more with NLPs. This is not the end of learning about NLPs. I only scratched the surface. You need to do more outside of this. Learn about naive Bayes, learn about logistic regression, matplotlib, dense, any of them that are related to NLPs. It's really cool. You can create all sorts of projects, publish it to GitHub, have other people look at your code. It's super neat. So I'm gonna go ahead and link this. Let me go ahead and link this. Let me copy link address. I want you guys to take a look at this. It's really cool. It's a free course and it's on Coursera. Let me go ahead and open it. And it's through Stanford and it's free. You can enroll. There's 3,500,000 people involved. You can find all sorts of information on here. They'll be giving great lectures. And I recommend just trying to do this if you have any time. It will really help you in understanding machine learning models better outside of just this 1.5 hour workshop that we just did and the ones previously. Did you take it? If so, is it hard to understand? I've never used this certain Coursera program, so I don't know this one specifically. It starts August 31st. What's the date today? Has it started yet? Let's see. It starts tomorrow. Okay, you guys should enroll immediately. So I have not done this course because it has not come out yet. But if you ever want to, go on Udemy. It's just basically a coffee's worth of, like, it's like $8. You can like buy a coffee sometimes for like about that much ish. Just pay for it on Udemy. Also, they have these deep learning ones, like courses. They have just regular machine learning neural networks that are only logistic regression and linear regression and so forth. It's really great. Udemy is amazing for that. Coursera is offering this. I really recommend you take advantage of this right now. So yeah, you could always like just take this course if you're wanting to learn more about machine learning. I believe this is the last presentation out of the workshop, but yeah, it's super exciting being able to present this to you guys. I really encourage you guys to keep going for machine learning. It's a really new topic. It's a new topic and it's been exploding recently. Take advantage of that. Get a great job out of that. Oh my gosh, I'm gonna go ahead and stop my share. I think that covers everything. I went over by like 8 minutes, but are there any last questions before I leave? I could leave my contact information if you ever want to contact me for anyone who's left. I'll go ahead and put it. You can contact me at my email or my Instagram and my GitHub is YunbiByte. You can see any of the projects I've worked on through GitHub. And yeah, you'd be able to look at anything. It's all of the code I've ever written. I normally publish it online. So you can go ahead and look at that if you ever want to. So, and I also recommend publish your code to open source. It's really cool. People can see everything you're working on and help you work on projects too. It's like a way to collaborate with people even though you're not in person. So I always recommend that. But I believe that concludes the presentation. It's nice being able to talk to you guys and show you a little a couple things about NLPs.
Thank you so much.
So are we gonna pause the recording there?